The first type of operator we'll be examining is arithmetic operators. So arithmetic, of course, that's relating to math. So these operators are used for basic mathematical operations. As you can see, all familiar ones: addition, subtraction, multiplication, division. One you might not be familiar with is the modulus. So this goes hand in hand with division. So division, we call the result of a division problem, right? The quotient, just like the result of an addition problem is the sum, result of subtraction problem, difference. Result of multiplication, product. Well, for modulus, the result's actually the remainder of the division between two numbers. So let's take a look at each of these operators in action. So we have addition, right? So say we have two variables, int a and b is equal to 10. Let's actually declare those over here in IntelliJ. So we're going to do int a is equal to 10, int b is equal to 3, and then we're going to output a plus b. And if our math checks out, of course, we should get 13. And yeah, that's the output there. Of course, we could also use the addition operator for concatenation. So let's say we made these strings. Of course, I'm going to get some errors from the compiler. Let me fix those. If these instead were string types, then no math is going to be performed. They're just going to be combined together to make 103. Because when you concatenate strings, right, it's literally just sticking them together. So 10, you add 3. Because it's a string, it's going to just put it as a sequence of characters, and we get 103 as the output. So those are the two use cases for the addition operator, adding, of course, and then also concatenating strings. So addition, of course, is for numbers. You could use it for doubles as well, floats, any number type that addition operator should work. Subtraction operator, same idea, right? Instead, it'll be subtraction. So if I change this to be back to my ints, and then I change this to subtraction, of course, if my math checks out, this should be 7. It does handle negative numbers. So you could do b minus a, and then you'll get -7. There you go. We have multiplication operator. So the operator is actually the asterisk symbol, on your keyboard. So we could do a times b. Order does not matter, as you know, with multiplication, so it's the same as b times a. That should give us, 30. So that checks out. So that's the multiplication operator. Division operator, let's check that one out. So a divided by b. So we're going to do a divided by b. So 10 divided by 3, well, that should be 3.3333. Infinite number of 3's, right? A repeating 3. Let's see what we get. We actually only get 3 here. Now, why does that happen? Well, it's because we're dividing integers. If we want to increase the precision at which we are dividing, we should change these to doubles. So if we do 10 divided by 3 as a double, we should get a higher precision. And there you go. Now, this 5 at the end, the reason that this happens, it has to do with a binary rounding error, essentially. So it's a limitation of how floating point precision numbers are represented in binary. So the best that Java can do working with binary right under the hood is use this 5 at the end to get us close to the actual value of 10 over 3, which is 1/3 essentially. Or sorry, 3 and 1/3. So yeah, 3 and 1/3 can't be exactly represented by a double. There are ways you can do this. One way is using a special class called Big Decimal, and then doing some like rounding and division tricks. But essentially, usually this kind of precision doesn't hurt your program. Now, if you do need like a super precise program, right, and this rounding issue is going to cause some errors in your results, because you do require that extra precision, right, then you can't just do regular old division. You're going to have to use something else. All right, so let's continue. So yeah, just a little bit of features, or you can call them bugs, of the programming language.